Exercise 2.3, question 3. Obtain all other zeros of this polynomial if two of its zeros are these. So basically they've already given you two of the zeros, and using these you have to calculate, you have to find out the other zeros. Now how are we going to do this? Well, it's pretty simple. It depends on, first of all, what you know about zeros, what about their connection between zeros and factors of a polynomial, and then what you know about dividing polynomials by another ones. Now, what we're really doing here, first of all, is you know two of the zeros of this polynomial. Now, remember, whenever x equal to a is a zero of any polynomial, then x minus a is a factor of that polynomial. Think about it. This is how you write all your factors. For example, 3 or 10 factors and it's equal to 0. Then you put each of them equal to 0, each factor equal to 0, to get a 0 of the polynomial. So here the 0 a corresponds to the factor x minus a. Alright, so here, since I have these two zeros, these two are really the a's that I'm looking for. So accordingly, what are the factors that I'm going to have? Let's think about that. So for the first one, where square root of 5 by 3 is a 0, the corresponding factor that this polynomial is going to have will be this, x minus square root of 5 by 3. Similarly, the other 0 is this, minus square root of 5 by 3. So if I do x minus of this thing, it will become a plus. So these are the two factors that this polynomial has. Now, think about it. If I talk about the number 15, then 3 is a factor. Yeah. 5 is a factor. Yes. The product of 3 and 5, which is 15, is also a factor of 15. Now here it just came out to be equal. Let me take something else. Say 20. Then 2 is a factor. Yes. 5 is a factor. Yes. So 2 times 5, 10, is also a factor of 20. Now in numbers it will not always work. For example, I might have taken the two factors of 20 to be 10 and 5. In that case, 10 times 5, 50, will not be a factor of 20. The reason is that this 10 already includes this 5. That is the problem. While in the first two examples, 3 and 5 were different, 2 and 5 were different. One of them did not contain the other. In polynomials, you don't have to worry about it too much. These two are definitely distinct factors, and one of them is not a factor of the other. So the product of these two is also a factor of this polynomial that we have here. Let me just give this a name so we don't have to keep saying it. Let's call this p of x. Then what I'm really saying is that this product is a factor of p of x. Now, if I multiply these two brackets to actually see what this is, it's going to be x squared minus 5 by 3. Really, I'm just using the identity a minus b times a plus b is a squared minus b squared. So this whole thing is a factor of px. Now, what do we know about factors? We know that if one polynomial is a factor of another, then when this becomes the divisor of px, your remainder will be 0. So what I mean is, when I divide this px, this entire polynomial, by x squared minus 5x, the remainder should be 0. Let me just do that division and then I'll play the video again. Alright, now here is the division. Look how when I divided my polynomial p of x by x squared minus 5 by 3, as expected, the remainder came out to be 0. This had to happen because it was a factor. So according to the dividend, divisor, remainder and quotient relationship, we can say that the dividend, which is p of x, is equal to the divisor multiplied by the quotient, so the product of these two, x squared minus 5 by 3 times 3x squared plus 6x plus 3 plus the remainder. Now the remainder is 0, so it doesn't really matter whether I write that or not. So this way I have expressed my polynomial, the initial polynomial we had, p of x, as a product of two different polynomials. Now see what we have to do further. Alright, so here's where we reached. Now remember, the goal is to find the zeros of this polynomial, and the zeros are what? These are the values for which the polynomial has a value of 0 overall. So you find the values of x for which px is going to be 0. Now for that we factorize the polynomial completely. Now this little bit I already know because you already had the factored form, and in fact from that factored form we multiplied it to get x squared minus 5 by 3. So this is what the factored form for this is. And when you put this part equal to 0, this is how you get the two zeros that you already know. Square root of 5 by 3 from here and negative square root of 5 by 3 from here. These are the ones I already know. And we had to find out the other zeros. So the other zeros naturally will come when you factorize this. Now what kind of a polynomial is this? This is a quadratic polynomial. Now how do you factorize a quadratic polynomial? You can use splitting the middle term. Now it's very easy. You could choose to take 3 common first, or you could directly factorize this. So 3 and 3, if I choose this directly, then the product that I want is 9 and the sum that I want is 3. So it's a very easy split. I will just write down my 6x as 3x plus 3x like this. Now you know once you do this, you have 4 terms, then you take common terms out from this like pairs. So from the first one what you're going to have is 3x, you will have x plus 1, and from here you will have 3 common and you'll be left with x plus 1. So if you write it in the factored form, one factor is going to be 3x plus 3 from these leftover items, and the other factor is going to be x plus 1, which is the common bracket that you had in both of them. So this is now the factored form of this quadratic expression. And then, as you know, you just have to put everything equal to 0. So you will put these factors equal to 0 as well. So when you do that for 3x plus 3, you will get the value of x as minus 1. Similarly, when you do that for x plus 1, you will still get x equal to minus 1. That means the other zeros that we were looking for are these, minus 1 and minus 1. So the other two zeros are identical. So here what I did was I factorized the quotient that we had got, and once I got the factors, I just put each factor equal to 0, and thus I got the other zeros. That's it. To just help you organize your thoughts a little more, I'll just organize this slide more so that you just see the factored form first. There you go. Now you can see the entire polynomial px in its factored form here. Here are all 4 factors. The first 2 we were given. So this one we were given because we were given the roots, the zeros. And these 2, the third and the fourth one, are what we found. And we're done.